The other focus of this chapter is sample size determination. If a confidence interval is too wide, it doesn't give us a lot of information. Check out this example. If we estimate the average summer income of all BGSU undergrads is going to be between 300 and 10,000, that's so huge it doesn't really give us any inference about the actual average summer income. So a way to control the width of a confidence interval is to have a larger sample size. The larger the sample, the more accurate our estimations will be. We've looked at this formula before for the confidence interval, a point estimate plus or minus this margin of error. Margin of error we use as M. So M, my margin of error, equals this Z alpha over 2 sigma over square root n. This is what Excel calculates for us with the confidence.norm formula. With this equation, solving for n and using algebra to solve for n, I get this formula. This will tell me what's my required sample size to get a narrow confidence interval within a specific margin of error. I'll show you how to use it. Example 4, we want to estimate mu to within 15 units with 90% confidence, assuming sigma is 85. So let's find n. I'm going to identify the information they give us. My margin of error is going to be this 15. I want my confidence interval to be within 15 units of the actual true population mean. So m is 15. My confidence level, 1 minus alpha, is 90%. Sigma they give as 85. Find n. Here I copied the formula from above just so I can start plugging in the pieces that I do have. I have my sigma of 85, m is 15. I need to find this z alpha over 2. I know that alpha is 0.1. Therefore, alpha over 2 is 0.05. So I need to find z-score 0.05. So what is this? What does that mean exactly? Z-scores, we know, follow a standard normal distribution with a mean of 0 and a standard deviation of 1. I want the z-score that has 5% to the left of it, a left-tail z-score, 0.05%. This is a little bit of review, but to find a z-score or a normal distribution value, when we're given a probability, we use norm.inverse. The probability, this must be a left-tail probability, 0.05. The mean, we're talking about the standard normal distribution, so the mean will be 0, the standard deviation will be 1. My z-score is computed. So the z-score that has 5% probability to the left of it, this is the number I plug in to my formula here. Now this, just use your calculator or Excel, go ahead and go through the calculations. You're going to get 86.9 with some decimals. Doesn't matter what decimals come after it, we will always round up. We're talking about a sample number of people that we'll survey or number of observations. So we can't have a decimal number of observations, and to be safe, we'll always round up. Rounding that number up, my required sample to fulfill these requirements, 87.